I'm Kamal. I want to talk about some earthquakes. Let's get into some earthquake discussion today. Big developments in Alaska yesterday. It is just a little bit after midnight, by the way, so that's why I'm saying yesterday. I really want to say today, but it's just past midnight, so I'll go ahead and say yesterday. Alaska was struck with a 5.7 earthquake. Now, I have not been doing these videos for very long, so I can't really go over June and July unless I want to backdate a bunch of videos. I'm not going to do that. But let's just get started with this 5.7 today, because I'm going to start doing this a lot. And this 5.7 was preceded by a 5.3 the day before yesterday. And it was preceded by a 5.4 the day before yesterday. And those earthquakes were preceded by this 5.1 here in Japan, September 7th. And then that earthquake was preceded by the 5.1 here in Indonesia on September 6th. Okay, do I need to keep on going? I guarantee you one of these earthquakes in this chain preceded that 5.1 in Indonesia. I guarantee it. I guarantee it. All I got to do is find one of these. September 6th. 5 magnitude. What was that? Was that September 6th as well? Oh, I'm going to have to adjust the filters on this to try to find that earthquake that preceded that. Not going to do that right now. Just take my word for it. Indonesia, 5.1. Japan, 5.1. Aleutian Island chain in Alaska, 5.3, 5.4. Those earthquakes, if you look at them carefully, they're on the same, pretty much the same epicenter. And that energy is grouping together because it was at such a short point in time. And it slammed into this corner of Alaska here at 5.7. Let me zoom out for a second and you'll notice, according to the Dutch sense method, these earthquakes are going to be equidistantly spaced apart. So from one earthquake to the next earthquake to the next earthquake, equidistant spacing is very important because you'll see the stepping stone path that they take in order to spark these events. And it won't be exact mile for mile, but it's roughly the same distance apart. So you got a 5.7, you've got a 5.3 and 5.4 and 5.1. They're roughly the same distance apart. And you can go further south to the 5.1. And they do fill in gaps in the middle with other earthquakes that are going to be coming in after that. But that's an explanation for another day. I don't want to get too complicated right now because we got a lot of folks in the Pacific Northwest and California that want to know what's going on, and Alaska as well. So the 5.7 already happened. Can't take it back. It happened. So now what's going to happen next? Folks in the Pacific Northwest, Oregon, Northern California, and Southern California, Central California, all of it, we've got to pay attention. Okay, so I'm going to zoom in here, and I want you to look at these lines. These are boundaries between tectonic plates. You've got the Pacific plate on one side, you've got the Juan de Fuca in the middle, and you've got the North American plate to the east of both of them. And the Juan de Fuca right here, I'm going to zoom in on that. The Juan de Fuca plate here is squeezed. Okay? On the other side of this blue line, north of Vancouver Island here, all the way south down to the Mendocino Ridge, just a little bit south of Eureka. That is a subduction zone. This is the one that they're doing, this is the one that's scaring everybody to death. And even though the thing only erupts with its massive energy once every 300 to 500 years, but it's so damaging that people just run scared every single day. I'm not here to make anybody scared today. I don't want to do that. So, but I'm bringing it up because you do, if you're interested in earthquake science, you may want to pay attention. I mean, hey, the smartest ones are going to survive. The ones that are ready are going to be the most prepared. And so I would probably prepare. And in fact, matter of fact, I'll tell you why I'll prepare. I didn't mention this earthquake earlier, but I'll mention it just briefly. See this 4.1? It's 180 kilometers deep. How deep do you believe the subduction zone is? Most people probably don't know. But it's approximately 50 kilometers deep. 40 to 50 kilometers deep. So if you've got a 4.1 coming in at 180 kilometers deep, and we know that it's going to skip its way into probably the corner of Alaska right there, the same place the guy hit with the 5.7, and work its way down to the Juan de Fuca plate, well, if it's at 180 kilometers deep, it might work its way underneath the Juan de Fuca plate. It might work its way deep into the Juan de Fuca plate. Maybe not underneath, maybe just right into the subduction zone. So you do want to pay attention to that, okay? Here's another view of the plate boundaries. This is a USGS map. I want you to look at this fault right here as I get in just a little closer. You see this fault that goes through mountains, the Alaska Range, the Denali Mountains here? That fault, if you get a bunch of earthquakes that are going to be very deep and they're within this fault boundary, it's going to push that earthquake down into the Pacific Northwest. You don't want deep earthquakes going to the Pacific Northwest because it just might get into that subduction zone. So luckily, you've only got that 4.1 that I'm worried about. But luckily, this earthquake, I believe right here, well, no, that's not it. Hold on. That's not it. I've got to zoom to a slower view here. See that 1.6? 256 kilometers deep. Luckily, it's just outside that fault zone. That's a good thing. It's going to push that deep earthquake into northern Alaska. This is part of the earthquake forecasting that is, it's good to know this stuff, okay? We don't want it to go down south. We don't want it to go anywhere near the Cascadia Subduction Zone. Because if deep earthquakes start collecting anywhere near Juan de Fuca, well, you've got deep earthquake problems in the Cascadia Subduction Zone. That's what we don't want, okay? But you always want to pay attention. You want to be diligent. Okay, now, we've established that the 5.7 happened in the corner of Alaska, but there was more, okay? That 5.7, there was also a 3.0. There was also a 3.4. There was also a 2.6. There was also a 3.0. There was also a 3.6 all today. Okay, and in fact, some of these yellows were probably within another day or two of that. So a lot of this earthquake energy, if it hasn't snapped at a weak point in the crust, it might group together and collectively cause a larger event. So as such, I am going to issue a warning for the Pacific Northwest, particularly Oregon, particularly Coos Bay, particularly Eureka, California, particularly, let's get a little closer in here. Let's get into, come on now, Gold Beach, Port Orford, Brookings. You guys have got to be on watch for some offshore activity, okay? Notice this bend on the Blanco fracture zone. You see that 90-degree angle pointing right into the coast of California? Matter of fact, you can even see the shoreline looks like it's bent from that. This is the first time I even noticed that. Use what you can observe with your eyes. It's great because it's going to help you if you want to predict. I'm sorry, you don't want to predict. You want to forecast earthquakes. So this is applied science. This is applied science, what we're doing here. I'm not rubbing lamps and having genies come out and then try to figure out, a genie said that the earthquake's going to happen. No, We're using observation and our understanding of how tectonic plates work and faults work. Today, on the Blanco fracture zone was a 4.0 off the coast of Oregon. A lot of earthquake energy out there. 5-6 days ago, 5.9 in Oregon, 4.1 Oregon, 3.7 Oregon. What happened today? Or what happened yesterday? Within the last 24 hours, I should say. Look at Nevada, 3.8. Also in Nevada, same location of the 3.8 is, I keep clicking the same 3.8. My stylus pen, come on now. Okay, I guess I got to zoom in a little bit more. So 3.8 and 4.6, okay? Let me zoom back out and then you'll try to figure out how did that happen. That energy shift came right off the Mendocino Ridge and the Juan de Fuca plate, Blanco fracture zone. It pushed into the land mass, worked its way through faults, and got all the way into Nevada. It happens. So you've always got to be on watch. But you notice it's literally right at the angle of the Blanco fracture zone, goes straight into Nevada. That's where it went. And sometimes it'll just go straight there through faults. Other times it will travel down the Gorda Escarpment into the Mendocino Ridge. And it may have done that in this particular case as well. But this general area, that earthquake in Nevada, more likely than not, came from the Juan de Fuca plate. And it probably was that September 5th earthquakes right there. And in Riverside today, or close to Riverside, near Temecula, there was some news. Some people were not happy, some grouchy people. Took a 4.0 earthquake right there in Murrieta. Okay? 4.0 earthquake in Murrieta. So I think that that's energy that shifted from the Juan de Fuca fracture zone. Now, why did I issue a warning for a similar sized earthquake, 5.7? Why did I warn for a 6 right here in the Juan de Fuca fracture zone over the course of the next 3 days, 3 to 7 days? I'll tell you why. The reason I did that is because the energy transfer from those earthquakes is going right down the fracture zone. And when it's going down the fracture zone, it's an easier path. Usually it loses some steam, but I'm giving it a little more credit because of the cluster of other earthquakes around it. So I like to issue a warning a little bit higher than you may think it would be, just because if somebody walks in, this is the first time hearing this, they're ignorant, they've never felt an earthquake before, you want them to be ready. You don't want them to have their guards too low. I don't want their guards to be too high either, because I don't want to create a panic. But I do want to respect the fact that using the same logic that I'm using right now, sometimes the energy does pull and increase. So I would warn for a 6 or maybe a 5, mid-level 5 with a bunch of other earthquakes around it. But I'll go ahead and issue that warning over the course of the next 3 days. And it may take 7, but usually it takes, for best accuracy, roughly about 3 days. So I'll be back to check to see how right or wrong I was. And if I am, quote unquote, wrong, I'm probably not truly wrong. What happens is that if the energy doesn't pull up and create one big earthquake, what generally happens is it fractures into a lot of smaller earthquakes that get spread around. And most people, since they live in Los Angeles, San Francisco, and all the big cities, they come out the woodworks talking a bunch of trash. Oh, what happened? The earthquake didn't hit. What happened? Well, you live in the big city, and you're just lucky that the epicenter of the smaller quakes wasn't up underneath your feet. But I guarantee you, if you feel a 3.5 right underneath your house or within a couple miles of your house, you'll be grouchy that day. You will, because your house will shake pretty well. Further away from it, 7 miles out, 10, 12, 15 miles out, okay, you might not feel it. But if you feel a 3.5 and it's underneath your feet, you will not be happy. You will definitely learn to respect earthquakes. So just remember that. You ever talk that mess to anybody who knows what they're talking about with these earthquakes, and they tell you what's coming. If that big earthquake doesn't happen and it fractures off into a bunch of small ones, and you're talking that mess, you didn't feel the epicenter. Okay, you got thousands of people in Ridgecrest, and they're feeling earthquakes every single day because they live right up underneath these 2.5s, 3.0s, 3.5s, not to mention the big ones that they felt, 6.5 and 7.1 in July. So just remember that. If you talk that mess, that smack, that trash about, well, you know, the earthquake didn't do nothing. Well, like I said, you were lucky and you weren't at the epicenter. Okay? Let's observe what we can observe here on this map. Had to filter out most of the small earthquakes because it just slows down the machine, spitting out thousands and thousands and thousands of earthquakes that are of small magnitude. But hopefully you can see enough to see these yellow dots here traveling down the San Andreas Fault or San Andreas adjacent, down other big faults capable of producing some nasty earthquakes in Northern California. And you'll see just a little bit north of Fresno here, and really it's happening in Parkfield area, maybe getting filtered out because the earthquakes are a little bit bigger, and so they're not showing on the map. But you'll see there's an energy shift that is transferring over to the east. And look at this right here. I'm shaking the map right there. You see that deep red? That is Owens Valley. And in 1872, Owens Valley ripped what may have been a 7.9 magnitude earthquake. So, I mean, that's what's being reported. It was a 7.9 magnitude in 1872. And then if you look at this big fault line, you Southern Californians, Central Californians, it dumps right into Ridgecrest. So we're playing with fire here. Ridgecrest is known to get big earthquakes, but Owens Valley can certainly trigger one. So this whole area is capable of some strong earthquakes. And I want to look in a little bit closer here. See this line that goes off the San Andreas? The San Andreas is the big bend here. Goes north and south. There's a line that goes east-west, okay, perpendicular to the San Andreas. That is known as the Garlock Fault. And look at that line. Study it because I'm going to switch screens. There's a little line north of it as well that runs in the same direction. It doesn't connect as solidly as the Garlock Fault does, but it is there. It just may not be completely visible on the surface. So there's a lot of these earthquake faults that have twins. It's like adjacent faults to help alleviate some of the seismic pressure. But that is the White Wolf Fault, which may have triggered the third largest earthquake in California history. At least that's what San Joaquin Valley is putting out. And that was a 7.7 magnitude in 1952. So 7.9 earthquake, 7.7 earthquake. We got some heat. Okay, these are some big, massive earthquakes in central Southern California. And the concern with the whole Ridgecrest sequence, with all these thousands of earthquakes, I'm switching to a different map here that's going to show more quakes, lower magnitudes. I'm going to zoom in here. See the two red dots? Those are earthquakes within the last hour, and that's the Ridgecrest area again. Very, very small magnitudes, 0.9, 1.0. That's nothing. People can't even feel those. But in the next 72 hours, they're going to start to see more, and those magnitudes are going to go up because there's more earthquakes that are going to hit the Juan de Fuca. But that's a tangent. This large group of quakes near Ridgecrest, and I'm going south now, Palm Desert, Cathedral City, Murrieta, Corona, Banning, Indio, Palm Desert, Rancho Cucamonga. This massive cluster next to the Salton Sea. This is the southern end of the San Andreas. Ends pretty much a little bit south of the Salton Sea. These two clusters are going to join together. It's only a matter of time. They've done it in the past. It's going to happen again. But you see Ridgecrest is a earthquake sink. It is trapped. The Garlock Fault that we saw on this other screen here is basically blocking energy from going further south. And the concern for Southern Californians is that as long as earthquake energy keeps entering the San Andreas, and that's always going to happen, but as long as major earthquake energy keeps entering the San Andreas, the fear is that, or the concern is that, the Garlock Fault is going to be triggered into what it's capable of being triggered to, which is a 8.0 or something similar to an 8-level earthquake event. It is capable. And if the White Wolf Fault triggered a 7.7, it doesn't look nearly as thick. I don't think it's as long. It's not as long as the Garlock Fault. If the White Wolf can give you a 7.7, then definitely the Garlock can give you an 8. Okay? And let me switch back to the smaller earthquakes. You'll see, actually, the Garlock Fault has a bunch of quakes here. I'm clicking on quakes from the Garlock Fault. 1.1 Johannesburg, 2.3 California City, 1.6 near California City, near Johannesburg. Oh, a little bit further west, near Tehachapi, 2.3. These are on the Garlock Fault. Look a little bit north of the Garlock Fault. This is the White Wolf Fault. This here is the White Wolf Fault, 0.8, 0.9, Bodfish, California, huh? Arvin, 1.1. And the White Wolf Fault is basically connecting some of that cluster of energy back into the San Andreas here. So all these faults are being activated right now. Look at this part of the map. Barstow, Victorville. I'm shaking it so you can see it, okay? Above Barstow, there's actually a fault system there. It's part of the Eastern Shear Zone. Some of the faults that you got to be concerned with are the Blackwater Fault, the Harper Fault, the Calico Fault, and others. And if you remember 1992, Southern Californians, I do, woke up from this. What happened in 1992? We had the 7.3 magnitude known as the Landers earthquake. That was part of this fault system right here near Barstow, actually south of Barstow. But it's one of those faults that can bring energy from the Barstow area and dump it into the San Andreas, the southern end of the San Andreas, and that triggered a 7.3. So north of Barstow is a fault system that leads to that, and my concern is that it's very possible that all these Ridgecrest earthquakes may cross through the Garlock and trigger earthquakes above Barstow to get that energy into the San Andreas Fault on the southern end near Palm Desert and Palm Springs. So anybody in Southern California, there's no reason to be cocky at all. Even Central California and even further north, northern Central California, back to the Parkfield area. Why do I say that? Well, Parkfield is responsible, it's on the San Andreas Fault, and it's responsible for the 1857 earthquake, which is arguably the largest earthquake in record-keeping history. It's between that and the San Francisco event. Those are both right around 7.9 magnitude quakes. And you'll see Parkfield is over here where Coalinga is, a little bit north of San Luis Obispo. And you'll notice that the earthquake energy that's going through the San Andreas is not getting through. There's a big gap there. And here's what's important for us Californians to realize is as this earthquake energy travels to the east and dumps into the Eastern Shear Zone and dumps dead ends in Ridgecrest, why is it doing that? The theory right now is that, or the prevailing theory is that the San Joaquin Valley is sinking. And it's sunk roughly 30 feet in the last 20 years. And so if you know that the earthquake seismic energy is going through the path of least resistance, which is the fault system, if you're aware of that, then when land is sinking, it's going to create faults that may not be on a fault map because it's relatively new, But seismic energy is going to follow where that bend in the crust that is sinking, and it's going to jump over into the eastern shear zone. But guess what? We know that the San Joaquin Valley's been sinking over the last 20 years, roughly 30 feet. But what isn't widely talked about, I haven't seen it from earthquake discussions and people who are real hip to earthquakes, is that actually this land has been sinking since 1920. And if it's been sinking since 1920, then you know it was sinking before 1920 because it's a valley. It's the San Joaquin Valley. It's not mountains. Mountains, they rise. Valleys, they sink. So more likely than not, this is something that's just, it's par for the course for the land of California and the topography here. The valley is going to continue to sink. That's what it does, as the mountains are going to rise. And perhaps what we can conclude is that, the USGS put out a report that it was due to all the water extraction with all the water wells and the irrigation for the farmlands, and that is the reason for the sinking land. But no, if it was sinking in 1920 when no one lived there, and it was probably sinking before that because it's a valley, and it was 1872 that the Owens Valley had a massive earthquake, well, where did the Owens Valley get that energy for a 7.9? It probably came off the San Andreas the same way it is right now. Cut off near Parkfield, dumped into the eastern shear zone, pooling the same way it's doing now, maybe to a different extent, but some similar event probably happened. And that's where the earthquake came from. And my theory for Parkfield is that it may have happened so much, created the same gap we see right now, that Parkfield just decided, you know what, I'm still the San Andreas Fault. I'm still boss. I'm the biggest fault here. And I'm going to go right on ahead, and I'm going to pop my way straight down the natural San Andreas Fault and go to the southern end of the San Andreas. So it's very possible that that happened. I can't prove it, of course. I wasn't here in 1857 or 1872. But it makes sense to me. Why is that line so thick? That's the natural path. Okay? Hope that helps you understand a little bit about California. Let me switch to a different view. Okay, I have switched here to a different view so you can see what happens here in California. Notice, yeah, we've got a bunch of earthquakes here, but right now they're all little, 2.3, 2.1, 1.1. We did have the 4 today in Riverside, or yesterday. People felt that, and we'll probably end up with the potential for a 6.5 event in Southern California, Central California. Again, the potential's there. Not saying it will happen, but the potential is there for that to happen. But notice the line, the plate boundary, as the San Andreas basically crosses into Baja California. They rename it. I don't remember what the fault name is. I don't have that in front of me, but they rename it. But it's, for all intents and purposes, the same plate boundary, and you can almost call it the same fault. But notice how it keeps going further south, splits off into a subduction zone underneath Mexico. And look at all these quakes in the subduction zone in Mexico. Keep going further south, you've got a bunch of earthquakes there. These are all over 4.5 too, over 4 or 4.0, excuse me. Keep going further south, Peru, Chile. Chile got a bunch of 4.0 and greater earthquakes over the last few days. So you'll see that the energy just keeps on flowing around this planet. It just keeps flowing, and it's going to break where it feels that there are gaps that need to be broken. But remember what I said earlier. This is from Dutch sense. Equal distantly apart is important, because that'll tell you, it'll give you an idea of where the next rupture will occur. So if you look at this 4.0, that happened. Oh, when did this happen? Wait. Oh, I already talked about that one. Okay, scared me for a minute. That 4.0, what's with this 4.0? Did that happen today? Oh, that was Riverside. Okay, I'm not sure if that 4.0 on Riverside is related to this 4.0 on the Juan de Fuca, but it might be. This might just be a fast-moving quake. Matter of fact, we're going to go back to... Actually, no. Common sense, okay? This 4.0 just happened. There's likely going to be another 4.0 or some similar-sized quake as long as it travels along the plate boundary. If it diverts off into the faults, away from the plate boundary, and it goes across the crust, that's when the energy starts to dissipate. It's like you keep water in a riverbank, and the water is going to flow in this river. It's going to go fast. It's just going to go in an organized path and keep on going. And it's usually going to go around the same speed as long as it's staying within the riverbanks. If water spills over the riverbank, the water still has momentum. It's still moving, but it may not move at the same rate. And that's when the earthquakes will start to decrease in size. And that is why, if I switch to another view here, pardon me, that is why when I zoom out here, matter of fact, hold on, I don't know if I want to do, well, yeah, I'll do all size earthquakes. Hey, hold on. What's going on in Ridgecrest? What's up with all these within the last hour quakes? What's going on? Okay, before I can even finish this, I said they're going to go up. I was clicking on 0.9s, and they're starting to tick up. 1.5, 1.7, 1.0, 1.0. No, hold on. I want these reds. That was a 2.0. Did you see that? Did you see that? I can't even finish this explanation without making a valid point. Right in front of you. 2.0. Okay, still 0.9, so we got some weak stuff. 1.7 just occurred. Okay, some weak stuff, huh? Okay, 1.9. But you know what? I see evidence that these sizes are going up right as I'm doing this video. 2.3. Okay, so as I'm talking to you, they're starting to jump. Nevada, 2.3. What's up with Vegas? You guys feeling a little shaken too. But notice, remember I told you, as long as it's going around the plate boundary, the earthquakes are going to be a similar size. But if it shifts and transfers through faults and ends up in the crust, they usually will start to dissipate. Now, I don't want to click on Oklahoma too much because they've been getting some heat, some pretty good size earthquakes. But Oklahoma quakes right now, 2-level events, 1.4. I saw 0.9 in there, 1.8. But usually if you go further east, it's getting weaker and weaker. 2.6 in Missouri, huh? Okay. 2.0. I don't think I have a big enough sample size because there's been a lot of earthquakes across California and the United States over the last few years, but you got a 2.3 in New Hampshire. So I like to think of these quakes on the East Coast as a relief valve for overflowing pressure on the West Coast. You'll see that happens time and time again. There's just been a lot of heat as far as earthquake energy, like this 3.0 in Wyoming a few days ago. And that's because a few days ago you had the 5.9 off the Juan de Fuca plate. So usually the further east you go, the smaller the quakes get because you're further away from the plate boundary. We can talk about why that happens in another video, but I think you got the gist of my point today on how to forecast an earthquake in California, Pacific Northwest. You got a good idea, and we'll continue this discussion another time. So I hope I was helpful to you. If you find my explanations useful, please subscribe. Please add me. And stay tuned because I'm going to have more.